So the product rule is a simple case, right? So the product rule is used whenever we actually have things being multiplied and we want to take the derivative of that. So let us quickly look on that example. For example, let us say we have equal to, say, f of x, and then we have g of x, right? So these two things are being multiplied. So the derivative is saying that dy dx is that we're going to write back the first function. Then that will be multiplied by the derivative of the second function. And then we're going to be adding back to the derivative of the first function, and then that is multiplied by the second function. So that is basically the principle of the product rule. Now, in handling the product rule, let us use a case like this. So let us say that we have y, hold on, all right, let's go. Y is equal to, say we have 3x squared minus 2, 4x plus 7. Now we can lighten this first one to f, we could lighten this one to the g, and then we operate based on this principle in terms of the rule right here. So there it is, we have our f, we have our g. All right, like this. We're gonna write back the first function. So we're gonna write back 3x squared minus 2x. And then we're going to take the derivative of the second function, which is 4x plus 7. So the derivative of that is just a 4, because we are only, this is a 0, and then the derivative of 4x is just a 4. And we're going to be adding that to the derivative now of the first function, which is 3x squared minus 2. So that is going to give us 6, because the 2 is going to come down, 6x, yes, and then that will be used to multiply by the entire function here, 4x plus 7. That's the second function. So let me quickly go over that. We write the first function, take the derivative of the second one, and multiply by it, plus take the derivative of the first function, multiply by the second function. And then right here, you could clear this up if we want. So depending on who is your teacher, this might be okay, or you might want to break this down some more. So let me just take another layer of it. 4 times, so let me distribute. So 4 times 3, that is 12x squared minus 8. And over here, we'll have positive 24x squared. 6 times that is positive 42x. Hold on, 42x, and then now from there we could put together some more things. For example, 12x squared and the 24x squared will give us the 36x squared, and then positive 42x, and then minus 8. All right, so we could hold on to that for now, dy dx. So there it is, we took the derivative using the product rule, and that is example 1. Let's go for example 2 of the product rule. Right. So let us say that we find ourselves with another example, and it's 4x to the 5th, all right, plus 2x, and this multiplied by, say, 3x plus 1. So dy dx suggests that we're going to write back that first function, because we're taking the product rule, we're writing back that first function as it is, right? And then that is going to be multiplied by the derivative of the second function, which is 3x plus 1, and this is going to just give us a 3. So it's going to be 5 times negative 4, that's going to give us, let me just put this here, negative 20x, and we reduce the power. And then the derivative of this is going to be plus 2. So we're talking about taking the derivative of that, and then it's going to be multiplied by this entire thing as is. All right. So there it is. That's how you'll take it. And this is the derivative. If you want to simplify, you could go further. the idea behind the derivative using the product rule is that we're gonna lighten the first function to f and the second one to g, and then the principle is that I'm gonna be writing back my f function, then I'm going to take the derivative of the g and multiply those, then I'm going to take the derivative of the f function and multiply by the g function. All right, so that's it for the product rule. Now the last skill that you really want to have is understanding the quotient rule. So here it is. So the quotient rule is that when we are looking at irrational functions, all right? So as you can see, we're looking at these here. So these would have been the rational function right there. And taking the derivative of that, you could see that we have the bottom function coming up first times the derivative of the top minus the top function times the derivative of the bottom function. All of that must be over the bottom function square. So basically it's just some rules that we want to make sure that we have as we go forth. Let us look on quick two examples. All right, so let us look on two quick examples. Let's go. All right, so we're taking the derivative, right, of a product rule, the quotient rule. So let us say that we have y is equal to, say, x plus 1 over x cubed plus 2. So y is equal to x plus 1 over x. Based on this idea, the derivative, so dy dx, is going to be that I'm going to be writing back my g function or the bottom function first. So it is going to be x to the third plus 2. And that will go beside the derivative of the top. So that is just going to be 1 because the derivative is x plus 1. The derivative of that is just 1. And the derivative of this is a 0. All right. This, no, minus the derivative minus the top function, that's a bracket, and then that will be multiplied by the derivative of the bottom function, which is going to give us 3x squared, all right? And then all of that will be over x cubed plus 2 all squared. And we don't have to worry ourselves too much about expanding the denominator. That's not necessary unless your teacher really asks for that. All right, so going forward here. All right, basically this is just x to the third plus 2 because it's been multiplied by 1, so that's fine. And then in this here, we'll definitely have, so I'm still keeping that bracket there. So we could multiply this. We're going to have a 3x to the third when we distribute 3x squared times x, and then we'll have 3x squared right there. All right, so we distribute that. And all of this is over x cubed plus 2, and that will be squared. All right, so we're at the end, right? So we have one last thing. We're just gonna push this through. So finally, I'll just say dy dx is equal to x cubed plus 2, yeah, minus, as you could see, this is gonna be 3x cubed, and then minus, it's gonna be 3x squared, and all of that is over x cubed plus 2 all squared. Finally, I would have minus 2x cubed when I'm linking the x cubed and the minus 3x cubed. Then I'm going to write minus 3x squared, and that's a plus 2 at the back. So I'm just kind of having my thing in a descending order. Not that you have to, it's just me. And then we have x to the third plus 2. And all of that must be squared. So that is my differential there using the quotient rule. So basically, the quotient rule, as you could see, we just have to follow that little pattern, that little pattern there, you know, this little pattern right there. That's it. The moment you're following this, you will not be wrong. Okay. Let's go for the last one. Let's go for the last one. Just doing 2 examples of each. All right. So y is equal to, say, 3x over 4x third plus 5. Again, we want to lighten the top function to f and the bottom function to g. And then, so executing dy dx, right? Executing dy dx is going to equal to, firstly, I'm going to write back my bottom function. So it's going to be 4x to the third plus 5. And then it's going to go beside the derivative of the top. So it's going to be derivative of 3x is a 3. Yeah. Let me right now. And then what we're going to do next, I'll have a minus. But normally, when I have a minus, I open this bracket here. It's going to be the top function, which is just a 3x. And that is going to be multiplied by the derivative of the bottom function now. And that is going to give me 4 3s 12 x to the second. And then this is the base 0. So 4 3s 12x to the second. Right there, and then I close my bracket. And all of this now is over 4x to the third plus 5, and all of that is squared. All right, so let's push it further. 3 4s, I'll get 12x to the third plus 15. I'm distributing there. Let me leave this right now. All right, it's going to be one term. So I'm talking about 36x to the third. It's the minus 36x to the third, all over 4x to the third plus 5, and that is squared. At this moment, though, I want to take one last simplification. I'm seeing where I have like terms there. So definitely the 12x to the third and the minus 36x to the third. When I put those together, I'll get negative 24x to the third plus 15. And I have 4x to the third plus 5, and all of this is squared. So there we go, using the quotient rule, how we could take our derivatives and be good. I trust that this made sense to you and that you have learned. Please like, subscribe, and drop a comment at Daily Maths Concept. See you next time.